Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video, we're going to take a look at the geometric definition for parabolas. So these conic sections, we can come up with geometric definitions for all of them in this chapter. And so for a parabola, the idea, and I'm going to sketch a graph of one that opens upward that has its vertex at the origin. So if we've got the vertex at the origin, we're going to have some kind of shape like this. There is a point in the direction that it opens from the vertex. So maybe somewhere up here, that's called the focus. And an equal distance below that vertex is a line called the directrix. And every point on this graph, say we pick a point here at random, the idea is that this distance and this distance are the same. Now, my graph is not very good, obviously, but that's the idea, that those two distances are the same. And the two distances for different points are going to be different, but the distance to the focus and the distance to the directrix will be the same. The distance from the vertex to the focus, we label that as P. And so if the vertex is at the origin, the focus is at 0p, and the directrix will be at y equals negative p. Now, if it opens downward, p is a negative value, and so y equals the opposite of p will actually be y equals a positive number. So if it opens downward, the directrix is above and the focus is down below. Now the equation in terms of this definition would be x squared equals 4py. So the number that's being multiplied by y is equal to 4p. That will give us the focus, and from there we can sketch, it'll help us to sketch the graph. We can include the focus, the directrix. I'm going to show you another way to get a couple more points at the same level as the focus. All right, so x squared equals 12y, and let me write down that general form again, x squared equals 4py. So I know that 4p is the same as 12, or that p equals 3. So our vertex was at 0, 0. The focus is going to be at 0, 3. And the directrix, let me use a highlighter for that one. The directrix is going to be at y equals negative 3. Now, if we move to the left and right of the focus, we can find a couple of points that belong on the graph. And what we know is that the width at the focus is equal to 4p. So it's 2p on each side. If I go 2p to the right, 2p equals 6. So if I move 6 to the right and 6 to the left, I get 2 more points on that graph. Now, to make sure that this is actually correct, what if we plugged in 6 for x? The equation was x squared equals 12y, 6 squared equals 12y, 36 equals 12y, divide by 12, y equals 3, which is right where I have it. So if I move 2p to the right and 2p to the left, I get a couple of points on this parabola for free. This one's going to look like this. Now, if the constant in front of y is negative, then this whole graph gets flipped over. The directrix will be above, the focus will be below. Let's take a look at one of those. X squared equals negative 4y. So again, the general form is x squared equals 4py. 4p equals negative 4, p equals negative 1. So the vertex still at 0, 0. We'll talk about what happens when the vertex is somewhere else in a later video. The focus is 1 below. The directrix is 1 on the other side. So that's at y equals 1. Ignoring the sign for p, 2p would be 2 times 1 or 2. I can move 2 to the right and 2 to the left of the focus. And there's a quick sketch of that parabola. That's it for this one. We'll come back in the next video and we'll talk about using that definition when they open to the left or right.